Hello everyone, welcome to another video of General Mathematics of Class 9, and we are starting off chapter 9, that is areas of parallelograms and triangles. So without wasting any more time, let's get started. So the first exercise of chapter 9 is 9.1, and it is a very simple exercise with only one concept that you need to understand. So let us try to understand that concept first, and we can finish off the exercise in a few minutes. So let's see what it tries to explain. It tries to say, what do you mean by two parallelograms or two triangles or any two figures that lie between the same parallel line and they lie on the same base? So which figures will you call that will lie between the same parallel lines and will have a common base? So let me draw two figures here. Suppose this is one parallelogram and there is another parallelogram like this. Okay, let me give a name. Suppose it is A, B, C, D, this one, and this is A, B, P, Q. Okay, so here I have two parallelograms. Let me draw another figure where this is one parallelogram and this one is another parallelogram, A, B, C, D and P, Q. Okay. Now which one of these two will be lying between the same parallel lines and have a common base? Now if you look carefully, in this figure A, B, P, Q and A, B, C, D, they both lie on the same base AB. This AB base is common. Here also the base AB is common, so they both lie on the same base. But do they lie between the same parallel lines? See, in this case, this DP is a parallel line, and the vertex of the parallelogram ABPQ lies on this line DP, right? Here DP is parallel to AB. So the two parallelograms are ABCD. Now does CD lie in DP? CD lies in the parallel line DP? Yes, of course. PQ, this part also lies in the parallel line DP. So that means we can say that ABCD and ABPQ, they both lie on the same base and between the same parallel lines. Which parallel lines? DP and AB. It will be clear if you go to this one. In this case the base is same, but parallel lines are the same. No, DC is parallel to AB and QP is also parallel to AB. But do DC and QP lie on the same line? No, they don't lie. Okay, I hope you understand this one. So AB is the common base for both the parallelograms, but they do not lie between the same parallel lines. See, AB and CD are parallel, but also AB and PQ are also parallel, but PQ and CD do not lie on the same line. That means AB is parallel to CD, at the same time AB is parallel to QP or PQ, but CD and PQ are not on the same line or are not the same line. Therefore, we can say that although they lie on the same base, they do not lie between the same parallel lines. Let us draw one or two more figures to make it even clear. Suppose I have a structure like this and I have a triangle like this. So A, B, C, D, E. So here AB is parallel to CD. Now I have to say whether this triangle AEB and ABCD lie on the same base and have the same parallel and between the same parallel lines. Now of course they are having on the same base, that is on AB. Both the triangle and the parallelogram are having the same base. But do they lie between the same parallel lines? Yes. CD is parallel to AB. Okay, here CD is parallel to AB. Now for the triangle ABE or AEB, the other vertex is E and E lies on CD. This point E is on CD. So since E lies on CD, therefore ABE and ABCD, they lie on the same base and between the same parallel lines. Okay, so if you are asked what is the common base, the common base here is AB. And what are the parallel lines in between which they lie? So parallel lines will be, which are the two parallel lines in between they lie? AB and CD. Okay, so I hope you understood this one. So that is how you can say whether two structures, parallelograms or triangles, whether they are between the same parallel line and lie on the same base or not. So this is how it should be. One more example is if I have a same structure like this, but the triangle is like this. So in this case what happens? They have the common base, but they both do not lie on the same parallel line. This AB is parallel to CD, but E and CD do not lie on the same line. So therefore they will not be between the same parallel lines. Another where the base is not the same is something like this. Suppose A, B, C, D, E, F. Here A, B, C, D is a parallelogram and this one, let's suppose G, and A, G, E, F is another parallelogram. Now here even the base is not the same. One of the bases is AB, the other base is AG. So here even the base is not the same, and they also do not lie between the same parallel lines because FE and DC are different lines. So that is how you understand. So in general, the basic thing that you need to look at is whether the base is the same and whether the other vertex, other than this line, the other vertex, whether they lie on the same line. If they are on the same line, then they are between same parallel lines. If the lines are not same, if they are one is above, one is below, then in that case it is not between the same parallel lines. So let us move on to exercise 9.1, which is a very small exercise, and let's try to solve the 6 questions which are given there. So here we are with exercise 9.1, and these are the 6 figures given, and we have to tell which of these figures lie on the same base and also between the same parallel lines, which you have understood just now. So look at number 1. Here these two figures ABCD is a trapezium and ABP is a triangle. Now they both lie on the same base AB and also between the same parallel line AB and CD. See, because in the trapezium the parallel lines are CD and AB, and also P, the point which is of the triangle APB, is also lying on CD. So they lie on the same base and between the same parallel lines. So therefore we have to write the base and the parallel lines here. So therefore the base is AB, of course, and the parallel lines are AB and CD. AB and CD. Done. We are done with number 1. Let's move on to number 2. Here the base is same, of course, SR, but the parallel lines are not the same. SR is parallel to MN, SR is also parallel to PQ, but are PQ and MN on the same line? No. So this is not our option. This lies on the same base but not between the same parallel lines. Clear? Let's move on to this one. Here the base is different. Here don't take this one as the base, take RQ as the base. In that case what will happen? This parallelogram PQRS is a parallelogram and QTR is the triangle. So in that case QR is the base, right? And are they between the same parallel lines? QR is parallel to PS. So in that case what happens? SPR is parallel to PS and T lies on PS. So that means they are on the same base and between the same parallel lines. So therefore in this case the base is QR and parallel lines are PS and QR. PS and QR are the parallel lines. Hope that's clear. Let's move on to this one. In this case what happens? It is somewhat like this, but the difference here BC and PQ are the base. So the base itself is not the same. Although they lie between the same parallel lines, the parallel lines are same in between which they lie, but the base is not the same. So as a result, here BC and PQ are the bases, two different bases. So therefore this is not coming into consideration. This one, look into ABCD, which is a parallelogram, and APQR, which is also a parallelogram. Now they are on the same base AD. Cool, this base is the same. Now look, APQD, this one, and ABCD, they both lie between the same parallel lines. Do you understand? Since this is one single line in which all the vertex lie, one single line in which all the vertex lie, and this is the common base. So therefore they are lying between the same parallel line. So in this case, what is the base? The base is AD, and the parallel lines are AD and this one BQ. AD and BQ are the parallel lines. Moving on to the last one, here we have ABCD and PQRS. So of course no, the base is not the same, they are different bases. Although they lie between the same parallel lines, the parallel lines are same, but the bases are not the same, so this is not coming into consideration. So here we have number 1, number 3 and number 5 which lie on the same base and between the same parallel lines. So that is all about exercise 9.1. I hope you understood, very easy. Now we will move on to exercise 9.2, and there is one theorem which we need to understand for that. So thank you everyone for watching this video, and until next time, cheers.